Okay, today we're going to move on to our last section. I know you've already taken a chapter test on this chapter anyways, but this section is kind of separate from the rest. The only thing that relates it to this section is that we're talking about complex numbers. The nice thing about this is that at the end of this section, I'm going to give you a couple of questions, and they will count as bonus to be added onto your test score. With the test scores, if you did not show work as you were instructed, you lost 1 point on every question that you didn't show work on. If you showed work and it didn't make any sense, then you lost a point on that question. A lot of you showed a lot of work that made no sense in its relevance to the question, but somehow you ended up with the right answer. A little strange. That being said, we're going to have another little section added on to our chapter test. Like I said, it's going to count as bonus points. If you don't do it, you don't get any punishment. If you do it, then you get bonus points added onto the test, but you have to have shown all your work. That takes us to this section. 2-9 operations with complex numbers. The complex plane is a set of coordinate axes in which the horizontal axis represents real numbers and the vertical axis represents imaginary numbers. What that means is, if we are looking at what we would traditionally think of as our coordinate plane, all our real numbers go across here. All our imaginary numbers go up and down this y-axis. So my vertical is now representing the imaginary, and horizontal is just the real numbers. So if I'm looking at this imaginary axis, this part would be 2i, 2i, 0. So this is 0 plus 0i right here in the center. And then this is my real numbers on the right and left, and then my negative imaginaries. So now if I have to graph each complex number, I can base it based off of what we just learned. 2 minus 3i means I go over 2 and then down 3. This is 2 minus 3i, negative 3i. Negative 1 plus 4i means I go back 1 on the real and up 4. Four plus I means I go out 4 and up 1i. And you'll want to label your dots so I know which one is which whenever I have you do an assignment on this. And then negative I means that I just go down 1i, and I don't go over it all because there's no number that goes along with it for the real number. So it's just negative I is here. So that's it for how to graph them. Absolute value of a complex number. So I'll give you some time to write this down. The absolute value of a complex number, a plus bi, is the distance from the origin to the point AB, which is in the complex plane, and it's denoted by absolute value of a plus bi. In order to find that, if I'm looking at, say, 3 plus 4i, to find that distance, or to find that absolute value of that, it means that I would take, this is 3 plus 4i, go over 3 and up 4, and then it's the I from the imaginary axis. I just take the numbers that are involved, 3 and 4. I do the square root of 3 squared plus 4 squared, and that will give me my distance. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. And again, I'll give you a little bit of time to write that down. Okay, so now this says find each absolute value. So to do that, I'm only worried about the numbers here. So I have 3 and 5, and you don't have to worry about the I. It just goes under the square root, and I do 3 squared plus 5 squared. 3 squared is 9, 5 squared is 25. So that's 9 plus 25. And that gives me the square root of 34. If I break 34 down, that's 2 and 17. And I can't do anything else with it, so that's my final answer. For part B, I only have one number. And that's because this would be like negative 13 plus 0i. So I don't have to worry about the 0i. I'm just focused on this. So it's the square root of negative 13 squared. The parentheses are important here, the fact that it's a negative 13 being squared, because that's negative 13 times negative 13, which would give you a positive 169. There was a question on our test that was like negative 4 squared, and a lot of people wrote that as negative 16, which gave them the wrong answer. If you're putting it into a calculator, make sure you put those parentheses around it, because it gives you actually 16. It's negative 4 times negative 4. So it's something to watch out for. And now the square root of 169 is just 13. Part C is very similar. I have negative 7i. So there's no number in front. That would be like 0 minus 7i. So I don't have to worry about that. And I just take that number. Negative 7 squared. It gives me 49. So it's the square root of 49, which is just 7. You notice something about these last two. I had this absolute value of negative 13. If it's just one number, I'm taking the absolute value. It's always just the positive version of that number. So this was square root of negative 13. My answer is just 13. Same thing here. Absolute value of negative 7i. That's just going to turn into 7. If that had been the absolute value of 7i, that's still just 7. It always is the positive value. All right, whenever we add and subtract complex numbers, it's similar to adding and subtracting variable expressions with like terms. We simply combine the real parts and combine the imaginary parts. And don't do anything else with them. So we're not combining our reals with the imaginaries, just combine each one of them. So if we look at this, add or subtract, write the result in the form a plus bi. Whenever I'm doing this, I'm just combining my real parts. So 4 plus negative 6. And then I combine my imaginary parts. 2i plus negative 7i. So 4 plus negative 6 goes together. And then that's plus 2i plus a negative 7i. Now 4 plus negative 6 gives me negative 2. 2i plus a negative 7i. That's like 2i minus 7i. So that's minus 5i. And so my final answer is just negative 2 minus 5i. I don't do anything else with this. I don't combine my real part with the imaginary. It just stays in this form. Alright, so if we try this one now, it's going to do the same thing. The only difference here is it's a subtraction. So now I have 5 minus negative 2. Remember, I'm keeping my real parts together. 5 minus negative 2. And then I have negative 2i minus negative 3. So then 5 minus negative 2 turns that into a plus. So it's 5 plus 2, which is 7. And then negative 2 minus a negative 3. That's going to give me negative 2i plus 3i, which gives me 1i. So it becomes 7 plus I. And that's my final answer. Okay, this is a good place to stop for the day. Tomorrow we will pick up here. I will not actually be in school tomorrow, so it'll just be a video. And you'll just watch the video of the rest of this work. So, hope everyone had a good break, and I'm glad everyone's back.